In 1965, chemist Stephanie Kwolek was working at DuPont trying to develop lightweight, strong fibers for tire reinforcement to replace steel. In one of her tests, she created a polymer solution that was cloudy instead of clear, not to mention was thin and watery instead. Now most engineers would have just discarded the batch because it was not what they were looking for. She tested it anyway. When spun into fibers, the material turned out to be extremely strong, 5x stronger than steel by weight, and was also heat resistant. The fiber found use in body armor and helmets, aerospace and automotive components, until displaced by carbon fiber, as well as ropes, cables, and composites. My company uses Kevlar as a strength member in many of our tinsel wire design for medical cables because of its strength and solderability. Polyester-based design are very unforgiving when soldering as the core can melt. In any answer to the question, the engineer or scientist had to be open to the possibilities of the failed experiment or test. Kevlar is a textbook example of rejecting assumptions about normal behavior, having an open mind, testing anomalies instead of discarding them, being persistent. Material science breakthroughs from process deviations. Sometimes I wonder how many plastics were ever developed because the processing window is so narrow. There is a similar story of how Teflon was invented, and really even vulcanized rubber. Engineering and science often reward people who dig a little deeper into a so-called failed experiment. One could only wonder that new materials or processes we have missed out on because they did not follow through.